Okay, so today's the first day of quiz review. Pause the video here and try these two warm-up problems. All right, so now you can quickly check your answers. I will show the work for both. For number one, I don't want to do this binomial to the 10th power. So if I make the inside our u term, then du dx is 5x to the 4th. So reorganizing my integral, that's 6 times u to the 10th, x to the 4th dx. So I wanted the x to the 4th next to the dx because I see if I multiply dx to the right, I get du equals, 5x to the 4th dx. So if I can match this here, so let me divide by 5, 1/5 du can go in the place of x to the 4th dx. So 6 times 1/5 is the coefficient. Now I'm going to do the power rule. Add 1 to the power, divide by the new power, plus c. I can hold the spot for my function. I'm going to multiply denominators and put my u, the x to the 5th plus 3, back in for u. And that matches the typed answer. I'm going to do the same thing for number 2. I'm going to make u 3x to the 5th, which means du dx is 15x to the 4th. It's 3 times 5, subtract 1 from the power. I see I have my x to the 4th and my dx, so let's get that isolated. All right, so I got 1/15 du equals x to the 4th dx. So when I rewrite my integral, I've got 7 u to the 1/2, and then x to the 4th dx, I'm going to replace with 1/15 du. All right, so doing 7 times 1/15, that's the coefficient. Add 1 to the power, so 1/2 plus 1 is 3/2, divided by the new power plus c. Dividing by this fraction is the same thing as multiplying by the reciprocal. Nothing here reduces, so I have 2 times 7, 3 times 15. I need my u function. I said u was 3x to the 5th. And there's our final answer. Let's see, does that match what I typed? Yep. All right, so for quiz review today, page 15 is your practice. All the answers are on page 16. Pause the video here. Do not just watch me do the review. You try it and then come back and check any of the problems you got stuck on. These formulas will be at the top of your quiz. You don't have to memorize them. You also get your packet bonus. All right, so you're pausing the video and trying all these problems first. Here there is no variable, so I'm going to input x to the first, because x to the 0, when I add 1, divided by the new power. So this is just 2x plus c. This is x to the first, so I've got x squared over 2 plus c. You could also write this as 1/2 x squared. Number 3, add 1 to the power, divide by the new power. The 2's divide. Add 1 to the power, divide by the new power. You could also make this 1/3 x cubed plus c. All right, for number 5, I can't do the antiderivative yet because I have a variable in the denominator. So I'm going to keep my integral symbol, make the power negative to move it out of the denominator. And so now I've got add 1 to the power, divide by the new power. Let's make this look nicer. There's an invisible coefficient here, and this has to move back to the denominator. So I've got 1 over -1, which is -1. X goes back to the denominator plus c. I'm going to need some more space. All right, for 6, while I copy this over, we can't do the antiderivative with the square root. I need an exponent. All right, so for 6, I got the antiderivative of x to the 1/2 dx. So now I can add 1. You need to see it written out. 1/2 plus 1 is 3/2 over the new power. But dividing by a fraction is the same thing as multiplying by the reciprocal of the denominator. So this is really 2/3 x to the 3/2 plus c. For number 7, to take the antiderivative, I can't have the x in the denominator, so I'm going to change the power to 1/2 and it's negative to pull that out of the denominator. Now I can do the power rule, add 1. I've got x to the 1/2 divided by 1/2. Dividing by a half is the same thing as multiplying by 2. And let's rewrite that as a square root. Now in 8, because we have a sum, you don't have to write it out like this, but you can think of it as the antiderivative of x plus the antiderivative of 2. So for x, that's x squared over 2. For 2, that becomes 2x plus c. Or 1/2 x squared plus 2x plus c. I hope you're remembering plus c on every problem. All right, for 9, add 1, divide by. So that just becomes x cubed plus c. Oh, this one I have to make a power. Add 1. So we get x to the 4/3 divided by 4/3 is multiplied by the reciprocal plus c. All right, for sine, the 2 carries to your antiderivative. The antiderivative of sine is negative cosine. So negative cosine x plus c. I'm going to copy these formulas to the bottom of my page. All right, for 12, the 2 coefficient stays in the antiderivative. The antiderivative of cosine is sine. All right, the negative 2 stays in the antiderivative. Sine goes to negative, so times, let's do it like this, times -1 cosine x plus c. So -2 times -1 is +2. The -2 coefficient carries to your antiderivative. Cosine goes to positive sine x plus c. All right, for 15, here we go, e to the x. 2 carries to the antiderivative. I'm actually doing the process of integral antiderivative. E to the x goes to e to the x plus c. Now let's look at the difference between 16 and 17. In 17, I see this outside power on the binomial versus there's no outside power here. So number 16 is not going to require a u. It's going to be similar to what we did in 8, where it's just that polynomial. So I can individually take the antiderivative of each term. Now let's simplify it. And we're done. Now for 17, your choice is, because it's only a squared power, I can do 3x plus 2 times 3x plus 2. Or you could try u substitution. It's a personal preference. One way may not work. I don't know if the u substitution would work. So let's try it with the u substitution, and then I'll do the algebra way. So if u is 3x plus 2, that means du dx is 3. Ooh, I have that there. So if I multiply dx to the right, this would work. So I've got the antiderivative of u squared 3 dx. But 3 dx can be replaced with du. Let's go down. So then the power rule, and put your u function back in. Now, depending on the answer choices, because we're supposed to look here, that is m. So in the format of the answer choices, that's correct. So if this were multiple choice or matching, this would be the best way to do it based on matching to the answer choices. If you're totally stuck and u substitution is making you panic, because you have a squared power, you could rely on your algebra to multiply this all together . Oh, this is 12. And distribute the 3. And now you could do the power rule. And simplify. But your issue is this was not on the answer choices where this was. So I guess depending on the format of an assessment, you would have to be locked into one method over the other. If it's free response, you can choose either the algebra way or the use substitution way. All right, the last three here. I'm going to give them their own page too. All right, for 18, okay. I could multiply out this binomial and then multiply this. That's a lot of algebra. I'm going to use U substitution. Because x squared plus x is inside the squared term, and because the derivative of that is 2x plus 1, I know my u is x squared plus x. Because du dx is 2x plus 1. So if I multiply dx to the right, I get a direct match to this. So I got the integral of u squared du, because I'm replacing this part with du. That goes to u cubed over 3 plus c. Put the u function back in. All right, for 19, again, if I take the derivative of this inside piece, it matches this part. So that tells me my u term is x to the fourth plus x squared. So then du dx is 4x cubed plus 2x. And if I multiply dx to the right, I get du is 4x cubed plus 2x times dx, which matches this. So I've got the integral of u squared du. Oh, matches here. Okay, which is u cubed over 3 plus c put the u back in. Oh, 20 is a direct match as well. Huh, the warm-up was the hardest part of this whole review. All right, on 20, the inside part here is my u, because then du dx is 6x, which is here. So if it helps you to reorganize your integral to see what you have to match, an extra number would be fine, even though this matches. So I notice when I multiply dx over, this whole part equals du. Now I can do the power rule and put my u function back in. Okay. Since all of these u substitution problems had exact matches, make sure you can do the warm-up where we had extra values. Let me see if there's anything else here. Nope. Those are just the answers. And here's matched to the letters. Okay. I'm going to go back to the warm-up just for one last time. If this was tricky and you couldn't do it without my help, rewrite them down on separate paper and try them again.